All right, hi everybody. Welcome to the lecture portion of 2.5 and 6 kind of dragged together. The approaches to problem solving are part of section 2.6, but 2.5 introduces all these different equations and kind of asks us like how to solve for different pieces or of information surrounding motion specifically. Sorry. I'm sorry I'm not there. I miss you guys. Obviously, I wish I could be there. I have to wait until I get the results of a test, and once I do, then I'll be back. I'm hoping for Thursday, but who knows. That being said, let's go over some of the variables. So I just want to remind you of a couple of them before we go ahead and we get started with examples. This means average. So anytime you see the little line up above something, that means average. The little naught means initial. So the little 0 means initial. Same thing for position. Whenever we hear from rest, we're going to say that V naught or whatever it might be, whatever velocity it might be, is going to be 0. If we are given information about movement, sometimes we can also set the initial position to be 0. Okay, so just kind of some brief reminders of some stuff that we've talked about before, but are going to need to very much have committed to memory for this next set of equations. All right, so over here on the left, I've actually gone through, and your reading kind of went through and introduced each one individually, but I went through and I just kind of wrote down all 5. And we labeled them 1, 2, 3, 4, 5, and you'll see why here in a second. Next thing we're going to talk about before we start our first problem is the approach to problem solving that we're going to take. If we do it well initially, we will be able to do these problems no problem. When we introduce two-dimensional motion, if we change the variables to y instead of x, and some other major concepts that we introduce down the line here in kinematics. This is a topic we're going to focus on for a little while in this class because there's a lot to learn. So that being said, let's go ahead and let's go over the steps for problem solving. Number 1 says to examine the solutions to determine which physical principles are involved. I simplify that to draw it out. Number 2 is to identify our knowns. Number 3 is to identify our unknowns. Number 4 is to select an equation, and this is why we have 1, 2, 3, 4, or 5. For this particular topic, we have 5 equations, and one of them may fit better than another, and we'll kind of look at what we have. And then from there, it's solve the equation. And the last one, of course, is does it make sense? And we'll talk about numbers that make sense versus numbers that don't by looking at the overall course of motion. All right, so this first one is about a dragster. A dragster is like a car. A dragster can achieve average acceleration of 26 meters per second squared. Suppose that dragster accelerates from rest at this rate for 5.56 seconds. How far does it travel in this time? So we're going to draw ourselves a picture. I'm going to draw him going right. His acceleration was given as going that direction of travel. So his acceleration is positive, as will be his velocities. From there, we're going to make a list of all possible variables. And in the course of any equation, we have only a set number of variables. We've got initial and final position, so initial and final position. We've got initial and final velocity. We've got acceleration, and we have time. Those are the 6 different variables that we need to focus on for kinematic problems. And so what we're going to do is we're going to go through and we're going to try to identify what we were given in this particular example. So first thing that pops out of me is acceleration. We were given the acceleration to be a positive 26.0 meters per second squared. Okay. The next thing says that the dragster accelerates from rest. From rest means initial velocity is 0. Next thing we're told is how long it goes, and it says 5.56 seconds. One of the things I do want to point out here is that when you are plugging these in, you need to double check that you are using the correct units. And for us, correct units are meters per second squared, meters, and time should be in seconds. Okay, so just kind of remember that these are all the proper units that you should be doing, okay? Next up, it says, we want to know how far does it travel in this time. So it looks like we're looking for a distance here. We want to know how far it goes. Since we're identifying it as starting from rest, we can also identify its initial position as 0. So x naught is going to be 0 for us because, again, we're talking about from rest. Let's identify where it starts as 0. It'll make our lives easier. All right, so now I have 4 variables. I have x naught, v naught, a, t, and I want to find x. So what I'm going to do next is I'm going to go up into my equations up here at 1 through 5. And my goal is to pick an equation that will solve for x that uses x naught, a, t, and v naught if necessary. And so looking at number 1, we have v naught, but we don't have v final, so we can't really calculate an average velocity, because remember, with average velocity, which is equation number 2, you have to have both v naught and v final. So we can't really use 1 or 2. Next thing we have is number 3. It solves for final velocity given initial velocity, acceleration, and time. But we don't want final velocity. That's not our goal. Our goal is final x. Number 4 has x equals initial x plus initial velocity times time plus 1/2 acceleration time squared. So number 4 looks like an equation that we could use. Okay. Number 5 has v final, has v initial, has a, and has x and x naught. Since I don't have v, I can't use number 5. Okay, you just want to X them off as you go. So number 4 is really the only equation I can use. So I'm going to go ahead and I'm going to rewrite equation 4. In doing number 4 at this point, I have identified the equation. So step 1, remember, was to examine and draw a picture. Step 2 was to make a list of what we know. That's what these things are. Step 3 was to identify exactly what our goal is. That's what our circle is. And then step 4 was to find an equation. So I'm going to write out equation number 4. And from there, I'm going to plug in the variables I have and solve for the one I want. And it turns out the one I want is already on the left side of the equation, so I don't have to do any algebraic manipulation at this point. Since v naught is 0, that will get rid of this whole term. Okay, and when I plug it in my calculator, when you plug it in your calculator, don't forget that 5.56 is the only thing that is squared, multiplied by the 26 over 2, and you get x equals 406.88 meters. All right, so now we're going to do number 5. It says, does this answer make sense? Well, a couple of things. As the thing was moving, it was gaining 26 meters per second to its velocity for every second it was in motion. So after 1 second, it was going 26 meters per second. After 2 seconds, it was going 52 meters per second. After 3 seconds, it was going, X, Y, Z, right? Like keep on adding to the velocity, which means at some point, this car was going faster than 100 meters per second. So 400 meters per second isn't unreasonable. So we would go with sure. Now, if we got a negative 406 meters per second, or we got 4 million meters that it went, then we would probably want to go back and double check our math that we had plugged things in the correct place. Okay, well, that was the first one. All right, let's do the next one. So again, we're going to start with a picture. Then we're going to identify our variables. Every time you do a problem like this, you can start by just writing down variables. And then as you read, you can start filling them in. And sometimes you won't get all of them. Sometimes you might only be given 3 and asked to solve for a 4th. That's okay. Just keep in mind that our whole goal is to be used to how to solve these problems, okay? Very stepwise as far as how we treat it, okay? All right, so our first question says a car is going to merge onto a freeway traffic on a 200 meter long ramp. If its initial velocity is 10 and it accelerates 2 meters per second, how long does it take to travel the 200 meters up the ramp? So, you know, I'm going to draw myself my car. I know starting from here and ending here that it has to end at 200 meters. It was initially moving at 10 meters per second. Its acceleration is in the same direction as the motion, so acceleration is going to be positive. My goal looks like time, so it says how long does it take to get up to 200 meters. So my initial starting point is 0. My final is going to be 200 meters. I was given initial velocity at 10 meters per second. Remember that that's v naught. I was told acceleration is 2 meters per second squared, and I was asked to find how long. So here we are, steps 1 through 3 already done. Next thing to do is to look for an equation. Looks like I probably don't need the velocity final, so we're going to try and look for an equation that uses both x's, an initial velocity, and an a. And if we look back at our equations, number 1 uses both velocities. Remember, we don't have v final, so numbers 1 and 2 are already going to be crossed out. Number 3 uses final velocity, so we're also going to cross that out. Number 4 looks like a good candidate because it has initial velocity, which we were given. It has a time variable that we can solve for, and it has acceleration x and x naught. Number 5, unfortunately, looks like we're not going to be able to use it because we don't know our final velocity. So we're going to head down and we're going to start with equation 4. Again, look at that. Is it worth committing these kinematic equations to memory? Yes, but I think you'll naturally do that because we'll use them a lot in the coming weeks to solve problems. So if you want to memorize them, go for it. You will always be given these problems, but sometimes it's easier to just kind of commit them to memory because of all the different variables that are involved. All right, from there, we're going to plug and chug. So this is step 4. This is steps 2 and 3. And this is step 1. Okay. So I'm going to plug numbers in. All right, so I've got 200 equals, and this term goes away, 10t plus t squared. All right, guys, using your infinite knowledge of algebra, if you rearrange this, you're going to see that you have what we like to call a quadratic equation. How do you solve quadratic equations? That would be the quadratic formula. Ooh. So, one of the things to think about when you're doing this math, can time be negative? Hopefully all of you scream no at the screen, because no, time cannot be negative. And remember that the variable, the actual quantity that we are solving for is t. Because time cannot be negative, when we do this, one of our results is probably going to be negative, one of them is going to be positive. If you have the quadratic solver on your computer or on your calculator, should you use it? Trick question. Absolutely. You use the tools that you have. If you don't have that solver, see if you can get it from somebody because it's really, really nice. Otherwise, you're going to be doing the quadratic formula on your quizzes. All right, so what I'm going to do is I'm going to use a quadratic formula solver. I'm going to pause this and I'll be right back and I'll get you the answer. Oh, excuse me. So I went and I plugged it in and I got x equals negative 20 and x equals 10. Don't forget that these are actually numbers. Since time cannot be negative, negative 20 makes no sense. So our answer has to be that the amount of time it would take for this car to go 200 meters up that ramp at that particular acceleration is 10 seconds. And does this answer make sense? Absolutely. After 1 second, what we're doing is we're adding the amount of acceleration to the velocity as it goes. So for instance, after 1 second, it's going 12 meters per second. After 2, 14. After 3, 16 meters per second. After 4, 18. After 5 seconds, 20. And then you just keep adding to it. So after 10 seconds, this thing is going 30 meters per second, and meters per second means how quickly it's moving. So 10 seconds makes sense to me, and it should make sense to you. All right, let's do one more, and then I'm gonna have you work on number 4 as part of your homework for tonight, and you'll get the answer to number 4 with the answer to the problems you're going to work on in class tomorrow, okay? Or with the problems that you work on in class tomorrow. All right, so number 3, again, we're going to start with an airplane. Please excuse my drawings. My drawings are very basic, but they do what you need them to do. I'm really bad at airplanes. It's just like a fancy X, and then you erase very, very specifically. Oh, wait, maybe I was supposed to do it the other way. Sorry. Okay. So our airplanes, it says it lands with an initial velocity of 70 meters per second and decelerates. Remember that this is not a word. It has negative acceleration. That's how we work in physics. Okay, for 40 seconds. What is its final velocity? So when he lands on the ground, he's going to go some amount of distance. So this would be x and this would be x naught. He lands with an initial velocity of 70 meters per second. His acceleration points opposite the direction of his motion. So he's slowing down over time. And remember the dot diagrams that you've played with before where your velocity starts really big, and then it gets smaller, and it gets smaller, and it gets smaller as it goes. Okay, so for every second that he's in motion, he's losing 1.5 meters per second off of his velocity until he eventually comes to a stop. For us, what we're trying to calculate is what is his final velocity given all of the information that we were given. So acceleration will be negative. V naught is going to be positive, and then what we're going to do is we're going to set it up. So, oops, you know what I did? This is supposed to say x, and this is supposed to say x naught. All right, so we're going to say x, x naught, v, v naught, a, and then t. Remember, those are 6 variables every time for these kinds of problems. We aren't given a final x. We were given that he lands at some point, so let's define landing point as x initial. We were told v initial is 70 meters per second. We were told a is negative 1.50 meters per second squared. And we were told t is 40 seconds. So we're going to go and we're going to look for something that solves for our final velocity here given these variables. So let's go back up to our equations and let's look. So again, we're looking for something that gives us v given initial velocity, acceleration, and time. Looks like number 3 is already gonna be the one that we want to do. Now, does that mean that number 3 is the only one you could use? Absolutely not. If, for instance, you had enough information to use 4 or 5, you could use a different set of equations to get to your final answer. For us, number 3 looks like the easiest approach. So we're going to pick equation 3. And this was, of course, number 4 that we had to do on our problem-solving steps. When you do your problems, you should do all of the problem-solving steps just like I do. I just don't always label them. So this was steps 2 and 3. This was step 1. Draw yourself a picture. Put as much information in the picture as helps you, and then go and start filling in your variables from what you were given. For me, we said this is the equation we're going to use. So step 4 is to go ahead and plug and chug. I don't know v, that's what I'm solving for, but I was given 70 negative 1.5, and 40 seconds. So then I'm going to go ahead and plug it in. When you solve for the answer, I got this. Does it make sense that the thing has changed its speed dramatically or its velocity dramatically? Absolutely. Is it still moving in a positive direction? Yes, because he's still trying to go to the right. If at some point he starts going left, then you know something's wrong, because our goal is to stop the airplane, not get him to go the opposite direction from what he's going. So does this answer make sense? In my opinion, yep, it does. All right, so your homework tonight, I just want you to do this one problem on your own. And then, like I said, in class tomorrow, you're going to be working on problems like these to solve for different final variables. And what I want you to be able to do is set it up and use this information. So this is two separate problems. So you're going to have one set of variables for A and one set of variables for B. Some are going to be the same in both situations. What you're looking at is deceleration. Remember, acceleration in the negative direction is the proper way to say it, in two different situations. Okay, all right, so you will get that answer tomorrow first thing, so you can check your answers when you are done. All right, you guys have a good night.